let's take a look at another standard. This is A.SSE.2. So we're going to use the structure of an expression to identify ways to rewrite it. Essentially, we're going to factor these things completely, okay? So let's go ahead and let's take a look at one here. We got to factor a polynomial here, okay? So what I want you to do is I wanted to see if you can factor at least something out of there. Go ahead. All right, so hopefully you looked at this and you said, all right, I can factor out an x, right? There's a common factor of an x in each of these pieces, so I can look at this and I can say x, so this is times x squared plus 2x minus 15, okay? And I'm going to reverse it real quick, and I look x times x squared is x cubed, x times 2x is 2x squared, x times 15 is negative 15x there, okay? Well, then I'm looking at this part here, and I'm saying, wait a second, I think I can factor this piece as well. I think this piece can be factored as two pieces, right? Two of my factors of 15 are 2 apart, right? 5 and 3. So what I'm going to do is I'm going to rewrite this as x, and I have x, let's see, it's going to be plus 5, and then I'm going to have x minus 3. Okay, you're going to have to excuse my board is being really weird right now, and my pen is being extremely sensitive. And so hopefully it'll get better here. But so now I have this thing has been factored all the way. It's been factored completely. So let's go ahead. Let's try another one. I want you to go ahead and you try. See if you can factor that one. Go. All right, so looking at this, hopefully when we look at this, we can say, I see a common factor of 2y to the third, right? So I have 2y to the third power, okay, multiplied by, and then what's the remaining piece there? I've got my remaining piece is, let's get rid of that, okay. My remaining piece here is going to be y squared minus 9. Right? So y squared minus 9. So let's try this. 2y cubed times y squared is 2y to the fifth. And then I've got 18y cubed times 9. Or sorry, 2y cubed times 9 is going to give me 18y cubed. That looks right. I'm looking at this one. This is a difference of squares. So when I go ahead and factor this more, I can say 2y cubed times, and I've got y squared, so that's going to be y minus 3 and then y plus 3. Okay, factored completely. Again, I apologize. This looks very sloppy. My pen is being very weird. I don't know if it's my computer or the pen. So hopefully I get it figured out here pretty quickly. All right, go ahead and you try this one. Okay, hopefully looking at this, you said, ooh, I see a common factor of, anytime this wants to work, okay, a common factor of 4z squared. Okay, and let's see what's remaining. I've got z to the z squared, right? Minus, oh man. Oh great, now none of this is working. Okay. All right, z squared minus 4, whoops, that says x, that should be a z here. Let's make that a z. Okay, 4, okay, this is not acceptable. Let me fix this. Okay, let's try this again. Okay. Is it going to catch up here? Okay, so I'm going to pull out 4z squared, and that's going to give me z squared, okay, minus 4z. Okay, and then I'm going to get plus 4. Oy. Okay. Wow, I don't know what's going on with this. Let me try it. See if maybe something else works here. All right, so I'm looking at this. Can I factor this anymore? See if you can factor that anymore. Okay, hopefully you see that middle portion and you look at that and you can say that looks like a perfect square. So I'm going to take z squared minus 4z. That looks like I can say z minus 2 squared, right? Z, let's see, z times z is z squared, 2 times 2 is 4, 2 times z times 2 is going to be 4. Okay, and there we go. There you have it. All right, try another one. Okay, oh, that's right. I wanted to show you a couple ideas here. We have the sum of two cubes and the difference of two cubes. Okay, so you're going to probably want to write this down here. Let's start off with, just this one. Okay, so we've got x cubed plus y cubed is equal to, okay, when you factor it out, it's going to look like this. So then let's go ahead and, oh man. Let's go ahead and try factoring this one, right? So then I've got 125m cubed plus 64n cubed, right? So if I'm looking at this, what ends up happening is I'm going to take the cube root, right? This thing is the cube root of that. Well, okay, so if I take what times itself 3 times is going to be, wow. Okay, I'm going to have to just end up using the mouse here, so you're going to have to really pardon my writing. It's going to about to get real messy. Okay, this one, this x cubed, this x is the cube root of this, okay? So what we're going to get here is, this is going to be 5, right, times m, okay? And then I'm looking at 64n cubed, and the cube root of that is going to be plus 4n, okay? And then we're going to go ahead and we're going to multiply it. So then we're going to square. So x squared is going to be 25m squared, okay, minus x times y. So let's see, 5 times 4 is 20mn. So we'll 20mn. Okay, and then we'll finally do y squared. So that's going to be plus 16n squared. Okay, now that's the sum of two cubes. Here's the difference of two cubes. Okay, so what I want you to do here is I want you to try to factor that one out. Go. Okay, hopefully you said, okay, x right here is going to be 2a, okay, minus 5b. Okay, and then we're just going to do that same idea here. We're going to square this piece, so then it's going to be 4a squared. Okay, and then we're going to get minus 10ab plus, oh, sorry, not minus, plus, okay, and then 25b squared. Okay, there you have it. All right, let's try another one here. We've got 2 more to do. Why don't you go ahead, see if you can factor, start with this one on the left, see if you can factor that one out. Okay, so this one is called, what we noticed is called factor by grouping. What I'm going to do here is I'm going to look at, put 2 things together here, and then I'm going to see if I can get pieces left that are remaining the same. So watch, I'm going to group this one here, okay, and then I'm going to group this one here, okay, the 14x squared. Okay, so that's the idea. Okay, I can't really put parentheses around that, and you'll see why here in a second. Okay, so I'm going to pull out a common factor here. So this is going to be x squared. Okay, and then what's left over is I get x minus 3. Okay, and what I'm going to do here is I'm going to subtract a 16. Right, that's 16 is a common factor here. And what am I left with? Well, I'm left with x minus 3. Hey, look at that. So then, now I can use my reverse distributive property. So what I've got here is I've got x squared minus 16, okay, times x minus 3. Okay, I can't send this. I'm going to try to go back to the board. Let's try. Okay, so let's see if it's going to work. So then I've got x squared, so this is going to be x minus 4, x plus 4, all times x minus 3. Okay? That's great. It's not working at all. Might have to go back again. Okay, next we've got 16x to the fourth minus 81. See if we can try that one. Okay, so this one is actually the difference of two perfect squares. So what perfect squares do I have? Well, this is a perfect square, right? So this is 4x squared, okay, minus, it's not working, minus 9, right, squared. So what am I going to have here is I have 4x squared minus 9, and then I have 4x squared plus 9. Okay, and then this is also another one. So then this is another perfect square, or difference of squares. 2x minus 3, 2x plus 3, and then I get 4x plus 9. Okay, there we have it. Gives you enough information for tomorrow. Bring these notes. See you then.